Okay, looking at a second example of substitution. Remember, I'm asking myself, how do I change an equation that has two variables into an equation that has one variable? Well, I have to continue to remember I want to isolate the variable. Luckily, it's already done here in this equation. I already have a variable by itself on one side. Therefore, I know that P equals Q plus 3. So I can substitute Q plus 3 in for P into this second equation. When I rewrite my second equation, I have 3, let's write it first, P plus 2Q equals negative 21. I want to substitute Q plus 3 in for P because I know Q plus 3 equals P. Now I have an equation in the terms of one variable. I'm using my 5 rules once again. Number 1, distribute. Number 2, combine like terms. Number 3, variables on left side of the equal sign. Rule 4, variables on the, constants on the right. And the last step, multiply or divide. Now I know if I have parentheses, I can always distribute. I want to distribute this 3 to everything inside of the parentheses. 3 times Q is 3Q. 3 times 3 is a positive 9. Bring down everything else I have in the equation. Now moving on to my second step. Combine like terms. Are there any like terms on this left side of the equal sign? And I see that there are. There is a 3Q and a 2Q. So when I combine that, that is adding 3Q plus 2Q which will give me 5Q plus 9 equals negative 21. And then looking at my fourth step, constants on the right side. Well, I look and I see that I still have a 9 on the left side of the equal sign. It has to be moved to the right. But in order to move this, I have to do the inverse of what they are doing. And because they are adding 9, I will subtract 9. What I do to one side, I must do to the other. Positive 9 minus 9 cancels out and gives me 0. Negative 21 minus 9. When signs are the same, the rule is you're going to add these two numbers. 21 plus 9 is 30. And we are going to keep that sign. Keep the negative. Bring down what we have not used, which is a 5Q. I have that 5Q equals negative 30. My last step, multiply or divide. I've got to get Q by itself, and since Q is being multiplied to 5, I need to divide by 5. What I do to one side, I must do to the other. 5 divided by 5 cancels out and gives me a 1q, which is the same thing as just q. And negative 30 divided by 5, when you divide a negative and a positive, you know your sign is a negative. 30 divided by 5 is 6. So q equals negative 6. Now I have just found what one variable equals. I have not found what p equals. So I'm going to use that q equals negative 6 to plug into either equation, preferably the simplest, and I'm going to use this first equation. P equals q plus 3. Well, I saw that q equals negative 6. So I'm going to plug that in for q. And I will just simplify from left to right. Once again, we have to be careful with our signs. When signs are different, we have a negative and a positive. We're adding different signs. You subtract the two numbers, so 6 minus 3 is 3, and keep the sign of the largest, which is 6 is the largest number, so you keep that negative sign. I have now proven and solved for p to equal negative 3. Now I want to, as my third step, I want to write this as an ordered pair. Okay, so like x and y, you know that x comes first. Well, you sit here and think, well, what comes first in the ordered pair here? It's just kind of like the alphabet. X comes before Y in the alphabet, and P comes before Q in the alphabet. So it's going to be PQ. That's how it will work with all variables. So I have that my solution P equals negative 3 and Q equals negative 6. Now I have one last thing I have to check. Especially with all these signs, it's easy to make a careless mistake. So check. And I do that by writing down these two equations. And plugging in my two solutions. So I know that I'm saying that this is P and here is Q. So P is negative 3 and Q is negative 6. So signs are different. Once again, I'll bring down what's on the left side. It's by itself. Signs are different. Subtract 6 from 3, or 3 from 6, 6 minus 3, which is 3, and keep the sign of the larger. Negative 3 equals 3. That is true. Negative 3, negative 6 is a solution of this first equation, but it has to hold true for both equations for it to be a solution of the system. So negative 3 I'm going to plug in for P in this second equation. Negative 6 in for Q. And I am simplifying from left to right. 3 times a negative 3, positive times a negative is a negative 9. Positive times a negative is going to be a negative. 2 times 6, negative 12. Now I'm still not done simplifying on the left side. I have negative 9 minus 12. When signs are the same, two negatives, we're going to add the two numbers, 9 plus 12, which is 21, and keep the sign. Negative 21 equals negative 21. That holds true. Therefore, negative 3, negative 6 is a solution to the system of linear equations.